So these are the notes that I gave you on radical equation solving. And I'm not a big fan of giving you steps you must follow, but I'm telling you now, you must follow these steps. It's not going to go well otherwise. I promise. So please follow these instructions. Get the radical alone on one side. So in this case, my radical is sharing a side of the equal sign with this other term. So my first step will be to add the 5x to both sides of this scale equation. Now I have the square root of 3x equals 5x. Check. If there had been more than one radical and they were added to each other, I would move one to the other side. I would subtract one over to the other side so that when I squared it, I could just undo that square root. But you can't do that when you're adding two things on one side of the equal sign. And that's because we're going to raise each side. Now, think of the equal sign as a grouping symbol. The same as we do think of this radical as a grouping symbol. It implies that whatever's inside of it is basically in a parenthesis. And so we're going to see the whole side of each of these equal signs as if it is in a parenthesis, like a basket on a scale. And now we're going to raise those sides to the power that matches this square root. So since there's an invisible 2 index here, we're going to square this. This represents a half. When I raise it to the 2 power, I make it just 3x to the 1 power. So this does and undoes, if you will. Now over here, this is 5x times 5x, which makes it 25x squared. Because of that parenthesis, the square is applied to everything inside of it. And there's no sums to worry about here. We'll get to that one in a minute. But the next thing to do is to recognize that this is a quadratic. We need to use our quadratic tools. Actually, this is funny. I'm going to use the video. I'm going to turn the screen to include the board. Our quadratic equation solving tools are to get the whole thing on one side of the equal sign and 0 on the other. Once we do that, we have 3 solution strategies here. We can factor, which is the box thing, right? We can try and figure out if this ax squared plus bx plus c fits inside of these 4 quadrants. How do I make a length and a width to write it as a product? And then I individually solve each of those. Length might be 0 or width might be 0. Or if I don't want to factor and solve that way, then if the numbers don't work nicely, then I will use my quadratic formula. When it's set up here as ax squared plus bx plus c, my quadratic formula just straight up gives me the x values. One will be negative b over 2a plus square root of b squared minus 4ac over 2a. And the other one will be minus that, right? So those are my 2 solutions there. See how I got 2 solutions here, 2 solutions here? Or I could make vertex form, which would end up looking like x minus h squared plus k equals 0. Again, I would be manipulating this whole side, leaving the 0 on one side to make it vertex form. And then I'm going to subtract k square root and add the h. But when I take the square root, if I have x minus h squared equals negative k, whatever that is, if k is whatever. When I take the square root, I need to remember that this is plus or minus that square root. That's this square root right here. This one is that one. This one is that one. So now I get x equals h plus or minus the square root of the opposite of k. Okay, so 3 for perfectly valid quadratic solution strategies, all of which were tested in Unit 4. We're going to use the factoring one here because there is a GCF. Fantastic. When I do 0 equals 25x squared minus 3x, I subtracted 3x from both sides. Now I can see that there's a GCF of x, and I'm left with 25x minus 3. And here's where I split it. Either x equals 0 or 25x minus 3 equals 0, which means that 25x equals 3 or x equals 3 over 25. So my potential solutions are those two numbers. Solve for the variable. Check. All right, I checked that before. Now, the last step is to check solutions in order to throw out any extraneous solutions. This is a square root function, so it might have extraneous solutions, or it might have two. So, when I check 0, if x equals 0, then square root of 0 minus 0 equals 0. Okay, done. That was easy. Now we're going to check x equals 3/25. When I plug in 3/25 everywhere I see an x, that is the square root of 3 times 3/25 minus 5 times 3/25. I'm looking for, does that equal 0? Question mark. Well, I could bring this 3 into the numerator. When I multiply fractions, it's 3 over 1 times 3 over 25 gives me 9 over 25. All of that's under the radical, but I could think of it individually because division and exponents work that way. Not addition or subtraction, but multiplication and division do work nicely like that. And then this is 5 times 3, or 15 over 25, but I'd rather not actually go big numbers. I see this as 5 squared, so this becomes 3 over 5, right? So when I canceled out a factor of 5, numerator, denominator, I simplified that fraction to 3/5. And now I can see that this is 3 over 5 minus 3 over 5, and that does in fact equal 0, so I win. It turns out neither of these solutions is extraneous, so my solution set is 0 and 3/25. All right, I'm gonna go and do the one on the back now. Oh shoot, that's not what I meant to do. I needed to go to the next page. Here we go. So this is the problem on the back of your exit ticket. It is more similar to the one you'll see on the quiz and then eventually on the test. We're going to follow those same steps. I don't have them written here, but that's okay. We're going to isolate the square root. So I'm gonna look at this as though it is like A. So I'm really I'm trying to isolate the A. So I'm gonna subtract 1. 1/2 A equals negative x minus 1, okay? I'm going to then multiply both sides by 2. When I multiply both sides by 2, again, there is an invisible parenthesis that says I have to multiply the whole side by 2. So I'm going to simplify that and get that this is just A now, but this is 2 times negative x minus 2. Now, A really was the square root of 4x plus 12, so I'm back. By the way, in calculus, that's called a U substitution. I used A, so we'll call it an A substitution. It's a temporary way of simplifying the problem so that I can see what math I need to do. It lets me focus on what's important and what's not yet important. All right, isolated the square root. That is 5.1.1. That's your, that's 5.3.1, sorry. That's one of our learning outcomes. Now we're gonna square it. when I square it, I square the whole thing, which lets me undo this. 4x plus 12 equals, but this is not a matter of distributing the exponent. When it was multiplication across addition, it distributed. But this is not multiplication. This is negative 2x minus 2 times negative 2x minus 2. I need all the pieces of that binomial square. So this becomes positive 4x squared, positive 4x, positive 4x, and positive 4. So many 4's. So I get 4x squared plus 8x plus 4. Do not distribute, I will squirt you. I won't really squirt you, I don't have a squirt bottle, but it would be fun. All right, I will be tempted to squirt you. Now I need to realize this is a quadratic. Hearken over to my quadratic rules. I need to get 0 over here. So I'm going to subtract 4x to get, well, 8x minus 4x is 4x. I'm going to subtract 12 to get minus 8. And my 4x squared just comes along for the ride. Now I have this. But look at all those 4's, they're just screaming out to be simplified. What if I divide both sides by 4? Well, it's like dividing each individual term by 4. I'm distributing the division by 4, because division does distribute across addition, just not exponents. So I'm going to distribute that divide by 4, and now I have 1x squared. I'm going to write that over here. 0 equals 1x squared plus 1x minus 2. 8 divided by 4 is 2. Oh, that's so much easier. I would love to be able to factor that. Now, earlier I took my thing times thing and got the sum. Now I'm going to take the sum and try and get thing times thing, length times width. So if I can make this work, I will have 2 factors. So if I want to make negative 2, my things I can multiply by are just 2 and 1 or negative 2, or 2 and negative 1 or negative 2 and positive 1. Now which of those, when I add them, will make the plus x, the positive 1x? Well, I need to add 2 and subtract 1. So I'm going to go x plus 2 and x minus 1 so that my negative 1 and my 2 multiply. But now I get 2x here and negative x here, so those add to x. This is x squared. Great. So here I have x plus 2 and x minus 1, length times width. I get to break it up into those 2 separate equations because of the power of 0. X plus 2 equals 0, or x minus 1 equals 0. So x equals negative 2, or x equals 1. Awesome. Those are my potential solutions, but wait, there's more. Because I have to check for extraneous ones. So I'm going to check for x equals 1 first, because that's easier. So x equals 1. It's 1/2 times the square root of 4 times 1 plus 12, which is 16, plus 1 equals negative 1. So there's an x here, there's an x here. Both of those get replaced by the positive 1 that was there, which makes this a negative 1 over here. So 1/2 of 4, oh, this is not looking promising at all. Okay, square root of 16 is in fact 4, and half of that is 2. 2 plus 1 does not equal negative 1, so that's extraneous. If I made a mistake, please email me, but that's extraneous. Sorry, I haven't actually done this problem in a while. So we're gonna say extraneous, and we will not include it in our solution set. Now it's time to check x equals -2. I know you don't have the luxury of erasing, but and I only gave you a half page, but you can staple it into your notebook and use the whole page if you'd like. So I'm going to replace every x with -2. So 1/2 square root of 4 times -2 is -8 plus 12 is 4. And then I'm going to add 1, and that'll be -2, which is 2. So 1/2 of the square root of 4 is 2, plus 1 equals 2. Well, this is 1. Half of 2 is 1. 1 plus 1 equals 2. Hooray! We found a solution. The entire solution set to this problem is -2. It's the only x value that makes this equation true. Done and dusted. Hope that helped.